Welcome. We're in lesson 53 of Saxon Advanced Mathematics, aka Algebra 3. And we're going to talk about angular velocity. So angular velocity is it is like inches per second, miles per hour, feet per minute. It is how fast you're traveling in a given amount of time, but it's also in relationship to the size of a rotation or revolution of the wheel that you're traveling on. So let me give you an illustration. We have a wheel here, and it has this, it looks like a circle. Imagine that. And the center of the circle just happens to be right where the axle of that wheel is. Isn't that funny? So the distance from the axle to the ground, which is the edge of that wheel, that just happens to be the radius of a circle. Who knew? So the angular velocity is what the formula that we are going to illustrate here. Its velocity is equal to radius times omega. And omega is the angular velocity. It looks like a kind of wonky cursive W, I know, but it's omega. It is the radians per time. That's what omega is. So it's basically a relationship between the size or the circumference of the circle and how fast. Let me see if I can say. It's not how fast. It's the size of the circumference of the wheel or the circle in relationship to how many times this this axle or this circle is rotating in a given specified time. Does that make sense? Probably not. Okay, so think of it like this. Let's say this radius is 10 inches. So that would make this a 20-inch diameter, or a 20-inch wheel. That's how wheels are measured, in diameter. So we have a 20-inch wheel here, and it is traveling at 10 miles per hour. Okay, so we know that the circumference of this wheel is going to be 20 pi. And this is inches, so it's 20 pi inches. That is the distance that will be covered when this wheel makes one full rotation. This is one revolution of the wheel. That makes sense, right? That's pretty straightforward. It is just the distance around the circumference of the wheel is one revolution. Easy peasy, right? We got this. So if this wheel is traveling 10 miles per hour, then how does that relate to how many times around is this wheel moving to do 10 miles per hour? So the way we would solve that is we would look at first, so we found our revolution. This is our omega, right? This is what it's doing. It is going 20 pi inches one time around. Now we have to put that in relationship to time. So we're going to say, first of all, I've got a vehicle moving 10 miles, or this wheel is moving 10 miles per 1 hour. We're going to set it up just like a unit conversion. That's really all this is. It's just another unit of measure to put into a unit conversion. So we need to go from miles to inches to figure out how many of these we have. So we're going to go to 5,280 feet in 1 mile. That allows us to cancel, right? And I said this was going 10 miles per hour, right? So now we're going to go from feet to inches. So there's 12 inches in 1 foot. That allows us to cancel out feet. Now it's in inches. So now I need to go with revolutions. How many revolutions is that in 1 hour? How many times around is it spinning? So I just throw in my revolutions. I'm going to flip it because I need inches in the denominator. So 1 revolution is going to be 20 pi inches. So that allows me to cancel inches. And now I'm in revolutions. So my answer is going to be 10 times 5,280. And that's revolutions in 20, and I'm still in hours, 20 times pi, and that's hours. That's all you're doing. This is revolutions per hour. I wanted to know how many revolutions we were going. If the wheel was going at 10 miles per hour, how many revolutions is that in an hour? Well, that's revolutions per hour. That's what we just did. So you could do the calculation and you would find that, well, let's just see what we find. So first thing I'm going to do is I'm going to reduce this a little bit before I do this calculation. I have 10 over 20. So I'm going to reduce that to 1 over 2. I'm going to factor out that 10 because it's going to be the same thing. So this is going to be 5,280 over 2 pi. Right? And that's revolutions per hour. So I'm going to divide that by 2. 5,280 divided by 2 is 2640 pi. 2640 divided by pi, revolutions per hour. And if I wanted to, I could just go ahead and say 2640 divided by pi would be 840.34. So 840.34 revolutions per hour. How cool is that? I know exactly how many times it's going around 840 and 1/3 more per hour. Very neat. That's neat. For the record, there's a couple of different ways to do a problem like this. So let's look at our example problems. And as we do our example problems, I'm going to show you both ways. All right, so let me clear this and put this up here. All right, so here we have our first practice problem. 53.2. I know it's 0.2. The very first practice problem was just unit conversion, and you guys already know how to do that. So we're doing unit conversion here. So we're just going to refresh our memory during the problem. A wheel of a wagon has a radius of 14 inches and is revolving at 40 revolutions per minute. How fast is the wagon moving in miles per hour? So this is the way that I worked it, just using what I know about a circle and about unit conversion. I combined the two things together. And so I said, okay, if 1 revolution, the circumference is equal to 1 revolution of the wheel, the circumference we know is diameter pi, so 28 pi inches is 1 revolution. So that is this unit of measure right here. That is the unit of measure I created. I just put 28 pi inches over 1 revolution. And I created my own unit of measure for the sake of making this easy to solve. So that cancels my revolutions per minute. So I'm going to cancel, I canceled revolutions here by doing this, creating this unit of reference. And then I went to inches, so I canceled inches here and then went to feet. So I canceled feet here, and now I'm in miles. And miles is my ultimate unit of measure in my numerator. And then revolutions per minute, I want to go to hours. So I converted minutes into hours. And here's my unit of measure, hour. So I have 40 times 28 pi times 60 in miles, and then 12 times 5,280 in hours. So miles per hour. So this is the way I calculated it based on my understanding of angular velocity being the rotation being one revolution and the circumference being the distance of that revolution. Okay, so this is the way the book solves it, and it is using that V is equal to the radius times omega, where omega is your rate of your, it is your radians per unit time. So I have radians per minute. That's my unit of time because we were told revolutions per minute. And so we converted that with radians per revolution because we know 2 times 180 would be 360 degrees, but it also converts back to 3.14, right? You use it based on what it means. So we had 40 revolutions times 2 pi radians per revolution, which gives us 80 pi radians per minute because the revolutions canceled. So then you multiply this radius times the rate, the omega, right? This was the omega. That's what we solved for. So that was this. So here's our radius. Here's our omega. And then once we do this, then we do all the unit conversion we need in order to get it into what we want it to be, which is miles per hour. Right? So this is your radius times your omega. And then once we get that done, then you go from minutes to hours and from inches in the radius to miles. But if you look closely, I want you to just pay attention to the differences here. I need this pen right here. All right, so the 60 is the same in the numerator. 12 times 5,280, 12 times 5,280, and this, all of these three are the same. Our unit conversion here is the same. The only difference is where we multiplied by 2. That is the only difference. In this problem, the way that I did it, I multiplied to find the circumference. I multiplied that 14 inches by 2 before I did the calculation. I found 1 revolution. And in this calculation, it applies that times 2 with the radians. So I have 40 multiplied by 2. If you break it apart, this is still 14 times 2 times 40 times pi. And this is 40 times 2 times 14 times pi. The factors are still all there. It's just how they're grouped. Okay? So, what I would like for you to do, because of that, because it gets sticky, I would like for you to multiply anything that is like a revolution and that anything that has a pi together. And anything that is like a unit of reference. 60 is a unit of reference, 12 is a unit of you don't have to multiply those. You can leave those. So what this would look like for both of these, if you go back, this is 40 times 28. So it'd be 1120 pi, right? So 1120 pi times 60 over 12 times 5280. This would be, and that's miles per hour. This one would be, if you did it, 14 times 80, 1120. 1120 pi times 60 over 12 times 5280. And that gives us the same answer regardless of which way we solve it. Does that make sense? All right, that just keep in mind that's what I would like for us to be able to do, is to combine our radius and our radians and our revolutions into one factor, and in the numerator or in the denominator, whichever place it is. All the ones that are related to pi, calculate them together so that you can get one factor here, and then leave your unit of reference factors the way they are. That way you can solve it the way that you want to, because otherwise I'm going to have to, let me put this back the way it was. This is 28 pi. I'm going to have to account for all the differences that could be there. Right, and I won't know what those are. You know, I would have to solve each and every one of them. It's a lot easier for me to take whatever the book has here and just calculate these two together and give you an answer, because I can tell this is a unit of reference, and I can tell this is a unit of reference. I know what my unit of references are. So it's easier for me to take the other numbers and multiply them to get this number and put it in the fraction form. That's going to be easier for all of us, because then you come closer to getting it marked right in Jupyter if you do it that way. So that's the way we're going to do it. I'm not going to ask you to calculate pi. I'm not going to ask you to solve the whole thing. We're just going to take all of those little bits and pieces that could be different here and put them together. Just these two numbers, put them together so that you don't have to deal with all these variations that they could be. You know, I could say go ahead and solve the whole thing and give me however many miles per hour it is. I'm not going to do that. I just want you to get it down to this number and then all of your unit of references. And that should get us all the same. It just depends on which. You can do either way. You can solve it either way. It's good for you to know this. Velocity is radius times omega, and omega is going to be the revolutions per minute times your radians per revolution. So you can use that way, or you can use this way. This is the way that makes sense to me, because I took the time to figure out the circumference first. This kind of does circumference after the fact, if you want to think of it like that. Let's do another one and see what we get. So this is our second example problem. It says an automobile whose wheels are 30 inches in diameter is traveling at 40 miles per hour. What is the angular velocity of the wheels in revolutions per second? So here's the way I solved it, given how I know to figure it out, not necessarily using their equation here or their formula. So what I said was that a circumference is one revolution. The circumference is 30 pi inches, diameter pi inches. That's one revolution. And I created a unit of reference here for that. So then I converted 40 miles per hour into feet per hour, then inches per hour. Then I inserted my one revolution is the same as 30 pi inches, because it has the unit of measure that connects, which is inches. So that I canceled my miles, I canceled my feet, and then that allowed me to cancel my inches and turn that into revolutions, which became my numerator unit of measure. So then I converted hours to minutes and minutes to seconds. which became my denominator unit of measure. So my calculation at the end was 40 times 5280 times 12 in the numerator times or over 30 pi times 60 squared in the denominator. The calculation used by the book is that velocity is equal to radius times omega. We solved for omega because we're working backwards. So we solved for omega first, and we found that it is velocity divided by radius. So we did the velocity, which was 40 miles per hour, divided by the radius. And when we did keep it, change it, flip it, we got 40 miles over 15 inch hours. So we used that as our rate to convert. And we converted miles to feet and then feet to inches. Okay. Then we inserted our revolutions. 1 revolution is 2 pi. That doesn't do anything for us just yet, but we will get there. What that does is it gives us revolution as our numerator unit of measure. So then I converted, actually, inches canceled this right here. So the 12 inches canceled this inch back in the back, or back in the beginning. So then I converted hours to minutes and minutes to seconds. So that left seconds as my unit of measure in the denominator. So I ended up with 40 times 5,280 times 12. And then I had 15 times 2 pi times 60 squared. Okay, well, if we do what we discussed in our previous problem, and we go ahead and we multiply anything that isn't a typical unit of reference, which would be what we're used to using, which is the 5280, the 12, the 60. We leave those alone. We can't move the 40 around because that's just where it lives in the numerator and there's nothing to put it with. But what I can do is I can multiply 15 times 2 pi and I end up with 40 times 5,280 times 12 over 30 pi times 60 squared, and that is revs per second. So it's exactly the same thing that I have up here. Do the one that makes sense to you. That is my best advice. If this is confusing, do this one. This one makes sense. We understand circumference. We understand that 1 time around a circle is a circumference, and it's also the same as 1 revolution. So circumference equals 1 revolution. So you find the circumference, and then you can create your own unit of reference for that circle to do the math for you. Okay? If that way makes sense to you, do it that way. It's the same answer regardless. All right? That's all I have for lesson 53. I'll see you in lesson 54.